today we're going to take a quick look at some items from Chapter 5, the electron configuration and the arrow diagram and the Lewis dot diagram. To do the electron configuration, all you need to do is follow these arrows. So after 1s, then you would come to 2s. That arrow ends and you would come to 2p and then 3s, then 3p and 4s and so on. And then when you see the superscripts in the next thing we do, that would go up here, and it just tells you how many electrons there are. So if it's an S, then you would put up to 2 there. If it's a P, you could have up to 6. If it's a D, you could have up to 10. And if it's an F, you could have up to 14. So if we look at a quick example, let's say we were going to check out nitrogen. So nitrogen has 7 electrons. So first thing I have is 1s. S can hold up to 2 electrons, so I'll fill it. I need to keep going until I get to 7. So following the arrows, the next thing I hit is 2s. It can hold up to 2. Now I have 4 shown. I need to go until I get to 7. Continue on, 2p. Even though p can hold up to 6, I only need 3 more to make it to 7. So you notice that 2 plus 2 plus 3 is 7 electrons. So all you're doing is going until the superscripts add up to whatever number of electrons you were going for. When you do the arrow diagram, if I do the same one for nitrogen, it would be 1s2, 2s2, 2p3, and you just match it. So here I have the 1s2. And since it's an S, it gets 1 box, and there's 2 electrons to show. So the first one, the arrow's going to go spin up. Second one, arrow goes spin down. Next thing I am going to do is show these electrons here. I need 2 more. Since it is an S, it only gets 1 box, and I label it 2S, 2 electrons. So first one goes spin up. Second one goes spin down. Now I have 4 shown. I need to get to 7, so I still need to show these 3 from 2p3. So since it's a p, now it gets 3 boxes because there's 3 orbitals. And I put the electrons in. Now I have choices where to put them, so make sure you don't put them in the same box. In the S, there was only 1 choice. 1 box, so you had to put electrons spin up and spin down right away. Here we can keep them separated. So I have 1, next one goes in the next box, 2, and then 3. And that's it for nitrogen. Then when I want to do the Lewis dot diagram for nitrogen, it's the same electron configuration, which we just said was 1s2, 2s2, 2p3. You look at the energy levels, which would be these numbers, and you look for the highest one that you see. The highest one that I see on here is a 2, and so underline all the 2's. And then we're really just finding them that way, but we're showing how many electrons there are in each one. So that one has 2 and that has 3, so I need 5 dots. So I'll put the symbol for nitrogen. The 2 S dots will go on the side. 1, 2. And then the P dots go around the other 3 sides, 1 at a time. So I have 3 P dots. So I'll put 1, 2, 3. So I have all 5 dots shown, and I'm finished. One other quick example for today. Let's take sodium, one of the ones from your homework. Sodium has 11 electrons, so I would go 1s2, 2s2, 2p6, 3s1. Following the arrows is how we would get those. Those all add up to 11 electrons, so the electron configuration is done. Then I would do the arrow diagram. 1s2 has an up and down arrow. That would have been that one. Next thing I see is 2s. Spin up, spin down. Now I'm at 2p, 3 boxes because it's a p. The arrows go in 1, 2, 3, Now there's no choice but to pair them. 4, 5, 6. That's Hund's rule, or the empty bus seat rule. Don't pair them up until you have to. And then I'm back to 3s, and it just has one electron spin up, so I'm done. And finally, the Lewis dot diagram, looking at the energy levels. What's the biggest number that you see there? The biggest one that I notice is a 3, so I'm going to underline all the 3's. But then I really only care about that top number, which is how many electrons. So there's 1 there, so this is just going to have 1 dot. So I'd write sodium, and then I put in my dot, and I'm finished.